14.1.exe. So I'll say this up front right away. My answer is somewhat limited. I mean, I get the first few, I do believe, here, but then it gets into creating a signature with regular expressions and using base64 encoding, well, referencing characters generated by base64. So I'm not getting into that pretty heavy because it would just take too long. So anyway, when I run this program, I'm bringing up Wireshark. Say, well, I'll clear that signature and then I'll just run it. Okay, a whole bunch of stuff came across. So what we have is an odd looking string here, getting a file that turns out this is base64 encoded. We have an address that's useful for a signature. But okay, which networking libraries does this malware use? This is number one. And what are their advantages? Okay, well, that's the one I want to open. The one on the desktop. I don't think it really matters about saving it, but just getting into the habit here. Okay, networking libraries, functions, imports. So URL download to cache file A is one of the imports. It uses URLmon, the library URLmon. Let me double check the answer on this. Let's see. Program contains URL download to cache file function, which uses the COM interface. Excuse me. COM interface is good, it says here, because it uses Windows itself to generate HTTP requests and therefore cannot be effectively targeted using network signatures. So I guess it creates the user agent string. That's a big piece of it when you use that function. Okay, number two, what source elements are used to construct the networking beacon? Well, when we go in here and take a look, it's getting profile information, but we need to know where the beacon is created. And this right here is what I'm assuming the beacon is being referred to. Okay, so we have a couple things it's getting. And when you look, when I run it in Debug, I see this is very useful information running in Debug. File. Open. Okay, let me go back into IDAPRO because I want to go to a point where I know that that information is compiled, and then I can look at it. So we have a couple calls in here, one here and one here. This is main. Let's go through main. Gets hardware profile information. I think that's pretty key here. So, and the username. Prints. I didn't see anything printing to the screen. I'm not really sure what's going on there. So then it calls this procedure. Let me do, we'll highlight call. That's why it's easier for me to see what's going on with calls. this one up here. The fact is, we know that this is related to base64 encoding because we go, where is it, to strings. Okay, this one's called 401 OBB, but in strings, this is useful information right here. I mean, this is the beginning of it. I don't know why it splits my A's off on those. Let me hit back again. Back one more time. This is 401 OBB. This one. 41000. Oh, this one is referenced in 401 OBB. So we know that there's some base64 going on here. But I want to put a break at 401 OBB. Ollie Debug, Control G, 401 OBB, enter. Click, go. Okay. See, now we have something up here. This is the information we got from main, and it turns out this is GUID, which is a unique identifier for a computer and other devices, and then this is the username. So we know where the information is derived from. Now it turns out that, let me take a look and get back on track with questions. That answers number 2. Number 3. Why might the information embedded in the networking beacon be of interest to the attacker? If they know what type of user it is, they could log into the system or something like that. Oh, in addition, it's uniquely identifies the system. Let me look at the answer to 3 just to make sure. 3. The attacker may want to track the specific hosts, the downloader, and target specific users. Okay, wait a minute. The attacker may want to track the specific host running the downloader and target specific users. Number 4. Does the malware use standard base64 encoding? Well, I didn't look into that, but the answer is it uses an A instead of an equal sign for padding, so it's not standard. What is the overall purpose of the malware? Download a program and run it. That's what I'm assuming. Yep, that's what. See, the whole thing is, it wasn't clear to me that that's what it was doing. And that's what the answer says, but in Ollie Debug, if we go to main, where is it? Get to main here. Yeah, this is main. Then here, this call down here, it does a query, URL download to cache file, and then down here, further down, it creates process, and apparently that's what's running the program and downloaded, but I can't follow how that's happening from here to here. I don't have an explanation for you. Now, what elements of the malware's communication may effectively be detected using a network signature? Well, the address, practical malware analysis, but I was thinking, this is the piece that I don't have a lot of information for, any information. Turns out though that during the translation, what we have in this get, in this string right here, is some characters and then 6. 3 characters and 6, 3 characters and 6. So we can build that into, how many 6s do we have? 1, 2, 3, 4, 5. And then after that there's a T, 3 characters and a T. Apparently this right here matches up with, go back to Debug, these. The T, I think, is the minus right there. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 colons. So there's a pattern that it follows. I'm assuming as long as these numbers stay, these hexes, these bytes stay, they appear to be bytes of 2 characters each. You could look for, you could add another signature. Well, part of it could say, I don't know how you, the length would be variable, you know, but other than finding a signature with the position of the T's. Now if IDS could reverse engineer or, you know, decode this, then it might be helpful. Alright, enough talking. I don't think that it can, but okay, what mistakes might analysts make in trying to develop a signature for this malware? And they might make it too general. They might assume that the last character is A, and that's one thing here. What happens is they have this string here, but the whole string includes the A and doesn't have the slash. They put that slash and then the A there. But they may assume that it's this length all the time also. That's another thing. They could vary. Especially if they don't do this debugging, see the source, and like an IDA Pro. Chapter 14 takes a lot of effort to create valid snort signatures, stuff like that, or regular expressions. And I didn't get real deep into it, so I'm sorry if my answers aren't really full. The book has great detailed answers, but anyway, let's get started. Now, according to 14.2, they use a loopback address. Well, that doesn't work for me with Wireshark, which I want to use. So, what I do is I edit the resource. The loopback address is within the resource. Okay, so I'm going to look and find it here. Let's see. File, open. 14.2. Now we have a string table here. And there it is. Well, I'm in Resource Hacker, and this editing it doesn't work there that I know of. But I have downloaded this thing, a 30-day trial for Res Tuner. Looks good. I like it. I'll close the help file. Open. 14.2. Continue. String table. There it is. I just want to change this to think if I just close this out, it's saved. That prompted me to save it. But in addition, you gotta be careful with this one because it'll delete itself. So I make a copy here. Now I want to start. Clear the TCP stream. I'm gonna run it. This is just to see what's going through the network. Okay, we got some stuff. I think that eventually deletes. I don't know when. Oh, it aired out. That's good. It's good it won't delete. Maybe the error out has something to do with me changing the source file. I don't know. File TCP stream. So, tries to get information. HTML. Get a file, an HTML file. This user agent looks interesting. It's very long, and that's unusual. It's got looks like something similar to base64, if not base64. Try to look and see. Okay, hostname is a hard-coded IP address. So anyway, number one, what are the advantages or disadvantages of coding malware to use direct IP addresses? Well, according to the answer, one of the disadvantages, one of the disadvantages to the malware writer is that it can easily go into a signature. In addition, one of the things about it is if he uses a URL, all he has to do is change a DNS entry to make it a different IP. On the other hand, just the same, a URL could be a valid signature. So, okay, number two, which networking libraries does malware use? I'm going to go into PE view for this one. Yeah, it's in our data. So it uses WinINet, which is a high-level internet interface, and it produces all little bits and pieces of the communications to look like a valid and legitimate communication. If you use a lower level, it won't do that, and you may make a mistake that can easily be put into a signature. So WinINet makes it harder inherently to create a signature for it. Okay, let's see what else we have here. What is the source of the URL? It's in a resource. Now, what are the advantages does this source offer? It's sort of hidden. Go look in there and look at the answer. String resource section. Oh, it says here the attacker can use the resource section to deploy multiple backdoors to multiple command and control locations without needing to recompile the malware. Okay, well, that's news to me. But that's good to know. That's good to know. That's key, really. Which aspect of the HTTP protocol does the malware leverage to achieve its objectives? It uses this user agent string. Let's see if that's what the answer is. Yeah, HTTP user agent field contains application information. Well, it should contain application information. kind of information is communicated to the malware's initial beacon. I didn't know this, but apparently it is an encoded command shell prompt, and you can see information about that under details 6. What are some disadvantages in the design of this malware's communication channels? It doesn't encode incoming commands. Yeah, I'm not familiar with. I have to really look in there to see if it's decrypting and what the commands are. Number 7. Is the malware's encoding scheme standard? Let me look. This is where IDAPRO Free would help. And that's string. Well, anything with strings, really. But you really got to dig down in there if you want. Okay, this looks like it always puts an extra hex up there. But it's part of the. It's a letter. Anyway, I'm gonna cross references. That's not what I wanted. Control X. That's referenced a lot, but all the same routine, it looks like. This routine. So, this is a base 64, but a custom base 64 encoding scheme. Number 8. Okay, wait a minute. Number 8, how is the communication terminated? Sorry, I don't know the details, but the answer says keyword exit. And then when that's entered, malware tries to delete itself. Number 9, what is the purpose of the malware? Well, this is where it helps to go into IDAPRO and look around. And then if you look in, let's see, functions. This malware is a small, simple backdoor. Provides a command shell interface to a remote attacker that will be detected by common network signatures. Likely a throwaway component of an attacker's toolkit because it tries to delete itself. I've limited answers on 14.3, which is what we're doing here. Analyze 14.3.exe. So what I did was I ran it, but I have Wireshark listening. We can go in and see, well, follow TCP stream to see. So this is basically, this queries out beacon. What hard-coded elements are used in the initial beacon? Well, apparently, this is hard-coded. I don't know if that's in strings, but there's a few others. User agent is. This whole thing, I think, is pretty much static. Not sure if this is, but at least a big portion of it is. And then let me run this again so we can see right there, practicalmalwareanalysis.com. So it is querying that web page. What elements of the initial beacon may not be conducive to a long-lasting signature? PracticalMalwareAnalysis.com. How does the malware obtain commands? It reads the file that it gets. It gets a file. If you look in IDAPRO, there's a file name. This file name. It tries to open it. If it, let's see how this works. if there's a file there, it reads it. If not, it comes over here and looks for it. And the file is called start.htm. What example from the chapter used similar methodology? 3. I didn't know. Okay, it can get commands from inside NoScript tags, which is similar to a comment field. A legitimate page can have those commands in it, and you wouldn't see them. Okay. I do remember reading about that, but let's see. 4. What checks are performed on the input? I'm sorry, I'm going to have to skip this one. There's a half-page answer under short answers, and you can look under detailed analysis. 5. What type of encoding is used for command arguments? It's not base 64, but it's similar. Because under strings you can see these two go together. Not really sure what this is. It's a letter, or it could be a number or character. But this routine is the one that does some sort of decoding, and I can see I don't want to get into the details too much. See, I don't see anything encrypted up here. That's not data from server, though. I guess this is a decrypt. Decode. Alright, enough time spent on that. I don't know, so I'm trying to keep this real short if I don't know. What commands are available to the malware? Quit, download, sleep, and redirect. Let me see quit, or any of these in here if I see any of them. Search. Sleep. There's a sleep here. That looks like a DLL type thing. Back. This is where I'm going to start looking and not find it, so sorry, I don't have the answer to that one. What is the purpose? They say it's a downloader primarily. Number 7, malware is inherently a downloader. It comes with some important advantages such as web-based control and the ability to easily adjust as malicious domains are identified and shut down. See, I think one of the commands I found in here was, well, there's a place we can find all the commands. Where are we? Get back. Execute command. This one. Create a file over here. That's one thing it can do. Now run a command that's too generic. It's not really sure. I misnamed that. But again, yeah, I found create a file. I think it's that one. And then agent string. That's the big one. So those are a few. What they say is signatures that identify specific attributes of command and argument pairs, and that's coming the other way. I didn't look or know of any valid information coming in the other direction. So the signatures would be looking for user agent and the URL and some other things. Possibly, I don't know if that's a common string, could be. But you add them all together and it gets unique.